All right, so we won't have a whole lot to go through today, but just like we have started the chapters prior to this, as you look at that, I always like to start the chapter off by saying, what comes to mind when you see that term up there? Snails is one. Okay. I was just going to say what else comes to mind, and you said clams. You're correct in both cases. Anything else come to mind? Okay, so snails was said. So octopods is one. So and we, excuse me, we pretty much covered a lot of the classes that we needed to. So, do you think that you can tell? Do any of those have anything in common? We already said what they had. If you were listening, you'd probably know that. Hmm. So, what do they all have in common, do you think? Especially when you say clam. It's inside the shell, that's right. So, all mollusks will have a shell. That's one unifying characteristic. And another, darn it, excuse me. And another one would be it's a tongue structure called a radula. So we see these unifying characteristics in all the phylums. That's why they belong in those categories. Because when we talk about phylum Porifera, what do they have in common? They have an osculum. They can have more than one. What else? Sessile. They don't move because they're sessile. What else might they do? They're filter feeders, okay? Then there's one more characteristic that we could say that leads to their filter feeding, like you just said. Right, they're porous. If they have ostia, that means they're porous, okay? Then we moved on to the cnidarians. What do they have in common?
Tentacles.
They've got tentacles, that's right.
Radial symmetry.
They've got radial symmetry.
They have
And yes, they would have cnidocytes that have a function of doing what? Produce venom. That's right. Because when you look at some of these animals, whether it's a Chironex fleckeri or in Irukandji, those animals don't swim very fast. I mean, fast enough for what they need to do, because when they envenomate their prey, it probably halts them right then and there. And they have to, because they can't keep up with vertebrates that swim fast. So some of the form slash function or body plan of these mollusks, okay? And that's actually what it's called inside of a clam, is the head foot. So as we look towards the end of next week, okay, that will be approximately, I believe, your first activity in here. I believe we've got clams to look at. So what you do is you crack them open and identify parts of its internal anatomy. So do we have any oyster eater or consumers in here? You might be thinking, well, what's an oyster? Well, it's a type of food, for one. And since we bring it up now, it must have something to do with the phylum Mollusca, which it does. And in this case, we're talking about clams, which is in a class we call bivalvia. Okay? So when we look at some of these terms, okay, so this area of its body in front, because typically we think of head meaning anterior side, which is true, which you have to be careful when you're talking about orientation of animals when if they're quadrupedal or bipedal. Like humans, are we quadrupedal or bipedal? We actually start out quadrupedal, but now we are bipedal, like you correctly said. Because when you look at an animal that is quadrupedal, then, like that of a rhinoceros or a hippopotamus or the bovine family, the equine family, cattle and horses, okay, they have a distinct head and tail. Then they have a backside and a belly side, okay? But once nature selected animals to further evolution to the primates, we look at animals that can be bipedal now. So that must mean that the head region and front side now became the same, which it does, okay? Because animals that crawl on all fours, like we just said, well, not crawl, maybe walk, okay? You have maybe I should do this, okay? You have an anterior side, a posterior side, okay? A dorsal side, and a ventral side. Then we talk about primates and humans that are now bipedal. Now that ventral and anterior side are now the same. And then now you have a posterior and dorsal side. So that's the difference between bipedal and quadrupedal animals. But in this case, okay, the head region is going to be at the anterior side. So cephalic sensory structures, that meaning in, again, the head area, what might that mean for humans, like cephalic sensory structures? So it has to be in the head region. What do we have for sensory areas? Okay, all of those, your eyes, ears, mouth, that feed into a complex brain. Okay, of course, these animals don't have that. We're talking about humans now. So locomotor organs, one of the things that you're going to see is one of your vocab terms on the back page is actually called an open circulatory system. So what that means is it's an animal that has a pumping heart, okay? So that's a hallmark of evolution that we see. If there's a heart, they must have blood vessels, which they do. But one aspect that they're missing is capillaries, okay? Because when we say an open circulatory system, it is not pressurized. In other words, if there is some sort of internal bleeding in these animals, it means it's just going to pool in a certain area and it's not going to affect the animal because there's no pressure in there. When we have damage to our bodies or any animal with a closed circulatory system, that means it's pressurized. So then if you have blood leaking inside of that organism, that can present a problem, okay? But with these animals having a non-pressurized open circulatory system, it's not an issue. So blood just pools in an area, and then that muscle then contracts, usually this one right here, and that's how these clams actually kind of crawl along because of this structure right here. And I believe it's actually sticking outside of the clam. So what that would mean is that, okay, if this was our clam like this, okay, it's open just a little bit, and I think that head / foot is sticking out, and that's what they use to kind of crawl along. Okay, so when we're talking about a visceral mass, it's just meaning it's a protective structure that holds these internal organs in place. And we have something like that inside of us. It's actually called an omentum. Because what you can do, unfortunately, it does happen to some people, if you are squatting, doing weightlifting, or if you lift something too heavy and you put stress on your abdomen, that omentum structure can tear and perforate. Well, not perforate, it can tear, then your intestines pop out in that tear. That's what we call a hernia, okay? And that's something that might need to be surgically fixed. So what we have as that structure holding intestines in place, there's something fairly similar inside these animals, whether it's a squid, an octopod, a clam, snail. All of these mollusks have this structure that holds organs in place. So I think what we want to do is just wrap up with this. And then next week when we come back, then we'll start talking about these here. Okay? So as you see here, these folds of skin that provide a protective function, okay? Just like that visceral mass, and then this is just where all that is located. It's a cavity inside the mantle. And cavity just means open area. So when you're thinking, well, wait a minute, I thought we just said a visceral mass is what holds everything together. That's true. But this is just saying visceral means skin-like structure. So that's why this says two folds of skin that provide a protective function, holding a stomach in place, holding an intestine in place. And that's something that you will see when you cut these, crack, break, whatever you want to call it, cut these clams open. So again, when you just see cavity, it just means open area. Like a cranial cavity. What might that be for humans? What's in the cranial cavity? Your brain. What about, do you know approximately where your thorax is for humans? It goes that high, but not any higher. So a thorax, like you said, your neck, which that would be part of your thorax, down to the bottom of your diaphragm, part of your rib cage.
The theme for tomorrow night's football game will be.
So then if this is your thorax, you have a thoracic cavity. Okay? So then below your abdomen, down to your hips, excuse me, I said that wrong. Below your thorax, down to your hips, that's your abdomen. So if there's an open area there, which it is, what would you call that? And your abdominal cavity. That's right. That's where all your internal digestive organs are located. Cavity just means an open area. Okay, so we didn't have a lot to go over, but we've all been around long enough. We don't walk in here and just do nothing. So we will continue with this form and function structures in mollusks next week. And then I think one of the things you're going to see is these animals are going to start to get to be more interesting as opposed to a sponge that doesn't move. Maybe you thought the jellyfish were all right, but now we're getting to, like I said, animals that actually move. They're more complex, so it does get more difficult, and as it should. But with becoming more difficult, like we just pointed out, it's also more interesting. So that's all I have. We'll catch up to you next time.